Welcome to lesson number 1, factoring and applications. This next unit is going to be on factoring. So if you remember from grade 10, factoring is when you have a monomial or a polynomial, and you are given a monomial or polynomial as a sum or difference, and then you need to convert that into a product of a polynomial. So we're going to look at factoring by taking out or removing a common factor, factoring difference of squares, factoring trinomials, and then factoring by grouping. So let's look at these first few examples just to kind of jog your memories on how to do these. So for each polynomial, we need to factor it by removing the greatest common factor. All right, so if I look at this first example, the greatest common factor that I see here is going to be 5x squared. Okay, since I know that 15x cubed is divisible by 5x squared as well as 5x squared. So whichever number you're taking out, or whichever term you're taking out, will go on the outside of the brackets. And so we're going to be left with 5x squared. If I take 5x squared of 15x cubed, I'm going to be left with 3x. And then if I take 5x squared of 5x squared, I'm going to be left with 1. It's going to be minus 1 though, because I have this negative sign for my operation here. And so that's my final statement, is 5x squared times 3x minus 1. On this next question for B, I have 8p cubed minus 4p squared minus 4. If I remove the greatest common factor for each of these is going to be 4. I know that 4 goes into 8 twice, goes into 4 once, and goes into 4 once. So if I take out 4, I'm going to be left with 2p cubed minus p squared minus 1. All right, and I can't factor that anymore, so that's my final answer. For this next one, this is a little more complicated since we have two different terms. Before I factor this, I'm just going to expand this term. So if I expand it, I'm going to have 3y squared plus 6y minus 9y minus 18. Negative 9 times positive 2 is a negative 18. So I'm going to simplify this by adding my like terms. I'm left with 3y squared minus 3y minus 18. And now this is something I can factor a little easy. They're all divisible by 3. 3 times y squared minus y minus 6. And I can break down the middle term. 3 times y plus 2 times y minus 3. Right? The reason I know it's y plus 2, y minus 3 is because I know that I'm going to have to expand this middle term. And if you know that you have a number that two numbers whose product will equal this number and whose sum will equal the middle term, then you can start going through a list of numbers that are going to add up to either give you this middle term or multiply together to give you 6. I know that if I have a negative 3 plus positive 2, I'll be left with negative 1 or negative 1y in this case. I know if I multiply positive 2 and negative 3, I'll be left with negative 6. That's how I knew to simplify it to y plus 2 and y minus 3. Now let's look at these ones. Factor, if possible, using the difference of squares method. So remember when we were looking at difference of squares, if I have this first term, x squared minus 81, using the difference of square methods, that would give me x minus 9 times x plus 9. So it's just a monomial whose operations are opposite. And so this is the only time you can use the difference of square methods. All right, so this next example, if I have 25a squared, my first number is a perfect square, 25. So it has a perfect square, which would be 5. 5, if it's a squared, then it'll be 5a. And so one method of doing these types of questions is first by putting your brackets in and thinking about your perfect squares. If you have a 7 and a 7 that give you 49, then one of them has to be positive while the other is negative. Now if I look at this one here, this will not work because notice in these first two examples, it was x squared minus 8. It was x, and it has 25a squared minus 49. In this example, it's 9x squared plus 4. Since it's a positive, we can't use this perfect square method, and it's not actually a number we can factor. So we would say that is not possible. Now this next term, 16t squared, we could say that this is 4t minus 8 times 4t plus 8. But if we look at this number, then this is something that we can actually break down even further. So instead, something I can do is right away, both of these are divisible by 16. So instead I could say, I could take this 16 outside of brackets, and that would leave me with t squared. 64 divided by 16 is 4. So I'll be left with 16 times t squared minus 4. But look at here, in this middle term we can have a difference of squares. So it's going to be 16 times t minus 2 times t plus 2. And that is something that is fully factored. Next, where possible, factor the following trinomials by inspection. And so we just have to look at these and then factor them. So if I were to inspect this first one, a squared plus 11a plus 30, look back to one of our first examples. I knew that my middle term had to be a sum of these two numbers, the 2 and 3, and that my last term, 6, had to be a product of 2 and 3. And so I'm going to keep those rules in mind for these ones. So where possible, and factor the following trinomials by inspection. And so first thing I do is I think about factors of 30. So a product that will give me 30. I have 30 times 1, but if I add 30 and 1, no way they'll equal 11. I have 15 and 2, but again, if I add 15 and 2, there's no way they're going to equal 11. So 5 and 6. If I add 5 and 6, 5 plus 6 is 11, so that works. 5 times 6 is 30, also works, which means that my factors are going to be a plus 5, a plus 6. All right, next one. b squared minus b minus 30. So again, if we look at this first one, 5 times 6 was 30. 5 times 6 is 30. I know that 6 minus 5 is 1. I also know that negative 6 plus 5 is 1. And since I have a negative and negative, they can't all be positives, or they can't all be negatives, since the last two terms need to be a negative. So I know that that's going to be b minus 6 and b plus 5. So I know that at this point you might be a little daunted and maybe a little concerned that you're not factoring things properly or you can't do it quickly. Don't worry, it's one of those things that it'll become a stronger skill set as you practice more and get used to seeing these patterns. X squared minus 4x plus 48. Okay, so if I look at 48 and think about the factors, I have 8 and 6. If I multiply 8 and 6, I cannot get a sum of 4 out of those numbers. So let's think of other numbers. 48 times 1, same thing. I can multiply them and get 48, but I can't add them together or subtract them to get negative 4. And so that you're not actually going to find a factor where this is going to work. So again, this one is not possible. And finally, 3x cubed minus 21x squared plus 36. Okay, so the first thing we're going to do, if you see that a number is divisible by a number, if there is a greatest common factor, then we'll get rid of that greatest common factor first. And so my greatest common factor here is going to be 3, but not just 3, it's going to be 3x. I know it's 3x because 36x is divisible by 3x. X squared, that means I can have 2 x's, and that's 3 x's there. So there's certainly going to be 1 x in each of them. So 3x, if I take the 3x out of this first term, I'll be left with x squared. If I take the 3x out of this term, I'll be left with 7x. And then if I take the x out of this term, I'm just going to be left with 12. And now from here we can think about this 3x stays here, but we can think about the middle terms that we can factor into smaller terms. So I have x squared minus 7x plus 12 that I'm focusing on now. I have to think of two numbers, remember, that are going to add together to give me 7, but then when I multiply them, they'll give me a product of 12. And so right away I know that x is my first number since I have an x squared here. And let's think of the factors of 12. I have 2 and 6. They won't add up to give me 7. I have 12 and 1, same thing. But I do have 3 and 4. And I know that there needs to be a negative and a positive. And so I know that when I multiply them, I'm going to get a positive. So I know that it has to be 2 negatives, -3, and -4. Since 2 negatives, when we take the product of them, they will give us a positive number. Okay, so those ones are finished. Now let's look at the second, or the last example. Factor the following polynomials by grouping. Alright, so when we're grouping these polynomials, we're going to deal with them one at a time. So we're first going to group these two together. Alright, and then we are going to group these two together. And it'll be the same thing with this next example. We're going to group those and these and factor them by their groups. Okay, so if I factor this first term, x squared minus 5x, I can only factor an x out of each of these terms. Okay, so out of x squared and 5x, they're only divisible by x. So if I take an x out of x squared, I'll be left with x times x. If I take an x out of 5x, I'll just be left with 5. Next thing I do is I take a term out of here, so this is only divisible by 2, which would leave me with 2x minus 2 out of 10 would be 5. Okay, so the next thing we do is we put together our terms. I have an x minus 5, and an x minus 5 on both sides of my terms here. So when I factor them, I'll just be left with x minus 5, and then I gather these two middle terms, and I'll be left with x plus 2. All right, and so what I did was I gathered my x and my 2, and they became x plus 2, and then my x minus 5. Since both of these are multiplied by x minus 5, I can just multiply both of these terms together by x minus 5. Okay, so this next one, we're going to first get rid of everything on this side. So that's divisible by 3y, since I have a 6y squared and a 9y. I'll take the 3y out and be left with 2y plus 3, because 3y times 2y is 6y squared. 3y times 3 is 9y. Same thing over here. I can't actually factor this, but since we're doing it by grouping, what I'm actually doing is taking a 1 out of here. And so 1 times 2y plus 3 is going to be the same thing as 2y plus 3. And you'll see why I had to take this 1 out when I do this next step here. So just like we did in this example, we are going to group everything outside the brackets. So it's 3y multiplied by 2y plus 3 plus 1 times 2y plus 3. Okay, so when we're grouping, these terms here should always be the same, and these two terms should be different. So the different terms we are going to group together. Okay, so that'll be 3y plus 1. It doesn't really matter if I put 3y plus 1 over here or on the other side. It'll be giving me the same answer. And then I am going to group this term here. Give me 2y plus 3. Okay, so that is how you do, well, that's how you factor some questions in a few different methods. Alright, so I'd encourage you just to take a look at some of these guidelines for factoring a polynomial expression. All right, I'm not going to go over them in this video just for the sake of time, but do look at this page in your book. It's important. And my last question is to factor the following. Okay, so my first example here is 36 minus 9x squared. If I look at both these numbers, they're both divisible by 9. So I'll be left with 9 times 4 minus x squared, which is equal to 9 times 2 minus x. And my 4 is positive. Since my 4 is positive, that means I have to have 2 positive values there, but my x is negative, so that will leave me with a positive x value. Okay, and so for this last example, it's kind of similar to this one where the numbers are organized in maybe a different way than you're used to seeing. If this is the case, try not to worry too much, but just realize that it follows the exact same rules. Okay, so 28 plus 3x minus x squared. If it's written like this, all this means is that our x squared is going to be written over here now, and then the numbers that give us our first term and our middle term will now go in the front. Okay, so if I need to get a product of 28 again and a sum of 3x, let's think of our factors that will give us that. Okay, so I have 28 times 1. Obviously, it's not 28 times 1, since I need to have a sum of 3x from 28 and 1. So there's no way. I have 14 and 2, which again won't give us a sum of 3x. But then I have 7 and 4. 7 and 4 do give me a sum of 3x if I have 7 and negative 4, or negative 7. Well, actually, no, negative 7 won't give us that, but 7 and negative 4 certainly will. And so that means that since the first terms need to be positive, it's positive. But my second terms, my 3x needs to be positive, since the 7x needs to be positive, but this 4x needs to be a negative, and so we have to make this x negative, which will also give me negative x squared. All right, so there is our factored form of 28 plus 3x minus x squared.